All right, so let's gonna go. Let's continue on and look at some stuff from our last class related to the homework assignment. I know some folks had some challenges getting the stuff to move around, so we're going to go through some code for that today and connect it to our JSON. All right, so let's see, where are we? All right, so right now I'm in our prefab playground that we set up last time. Okay. Now, just to kind of show you my current behavior, I've already added in some code to this, and then I will walk through what this code does. Now, right now, the JSON is not hooked up, but I have our placeholder image in there, and I've kind of hard-coded some values. See where it says item 0, and I just said the cost is 5 for all of them. So I have item 0, item 1, item 2, item 3. All right. Now, when I hit the left arrow, notice that item 1 is now on the far left. Item 4 is on the far right. So I can keep hitting left arrow over and over again. Right now I have it loading just fake 10 items. I am hitting the left arrow still, but it's not doing anything else because I'm already at the end. Similarly, if I hit the right arrow, we see we move back towards the beginning. All right, so we're kind of scrolling through our images, even though all our images look the same right now. We want to hook it up with maybe either a different image, or at the very least, what we're seeing change right now is the text. All right, so let's spend some time looking at how we accomplish something like this. Now, remember, the ultimate goal here is that we can then take this collection prefab and drop it into our scene or any place in the game where we want it, and it already has these behaviors. So we just kind of almost like you're fixing your car or something like that. You buy a part, and now that part does what it's going to do, and you just have to install it. And installing it might mean connecting up a couple of wires and that kind of stuff, and now it works. So the same thing's true here. We're effectively inventing a part, and that part can then be hooked into our code where appropriate. All right, so let's look at some of the code that accomplishes something like this. And then what I'm going to do is extend the previous assignment until Monday, because I know folks had challenges with this part of it, and I want the focus really to be on the JSON part of it. So let's take a look here, and we'll go from there. Okay, so if you remember, we just have our collection initially, and inside of that collection, so a collection is just our empty game object. So all that guy is a transform, and inside that we have a background. Now, last time we had a couple of placeholders that I've now moved into their own prefabs. So I'll show you that here real quick. So in my prefabs folder, notice I have my collection, and then I also have a single item. So this is my item prefab. So all this guy is a game object that has a material on it, and that material is based on our image. So let me show you that from last time. We had drug an image in here called item placeholder, if you recall. And if you click on that, the one thing we didn't do last time that I had forgotten about, because I was trying to drag it over to the side. So if you just drag an image in, let's see, do I have any other images in here that I can, well, here, let's just go grab an image of like a potion or something like that. Call it game potion image. Good enough. So we're going to steal this guy. And we're going to call this guy potion. Not working. What did I hit? Let's try that save again. potion.png. So I just saved it to my computer. So I'll go back into Unity and I'm going to go ahead and drag that image into my images. So it comes in as just a normal picture. All right, now if we want to use this inside of our games, we have to effectively convert this guy into a different format, a format that's now usable by Unity. And this is a common thing in game programming. We need to turn it into something called a sprite. So it's kind of an optimization of the image so that it doesn't, it's more memory efficient and things like that when you start putting into a game. So I'm going to click on our image here. And up here where it says texture type, it's brought in the default texture type. If you click on that, notice it has a whole bunch of different things you can convert it into. The one we're looking at is something called a sprite. This is a 2D image. It's also compatible with our user interface stuff for canvases. But I'm going to just select sprite here. And then when I click back over here, it's going to ask me if I actually want to make that change. So unsaved, changes detected, unapplied. So it's effectively going to import a brand new thing for me. It's going to do some extra magic. So when I hit save there, notice it has now put, let's see, hold on a second. We now have this potion sprite. And what I can do here is if I want to click on my item prefab here, right now it has this material on it that's this guy. If I drag this guy over here, give me my new material. Yeah, here's our potion material now. It's a little bit upside down, so well, we can just rotate our thing or whatever. So I'll go ahead and do that. So we'll take our item prefab and we want to rotate that guy because now my image is upside down. Actually, we probably want to rotate our sprite. Do I have a convenient way of doing that? I probably should have rotated it externally, but it is kind of weird that it brought it in like that. I rotate the material itself. This is an example of kind of the benefit of sprites is you can set up a tiling thing so it'll repeat the image multiple times and stuff like that. So think about games like Super Mario Brothers where you have you know, the platform he's running on, the bricks. Well, you know, really that's one image repeated 100 times or something like that. So this would be a speed up by being able to change the tiling on it and things like that. Well, in any case, it'll just be upside down for right now. We'll just say that's okay. You could mess with rotation or whatever to get it right, but that's how you convert it to a sprite. And now my item prefabs have this picture on it instead of that placeholder picture. You can always, and notice this is coming in as a material. All right, since it's coming in as a material, you can programmatically change the material associated with your items. So for example, let's actually do this so we can see it. I know I'm going out of order here a little bit because I wanted to show you the code, but let's just alternate it real quick so we get a little bit of visual changes. So I'll go back into my scene. Actually, you can get to it by just hitting the back arrow up here because I was in my prefab editor. So I'm in the scene here, and what I'm going to do is right now, when I click on my collection, notice the collection is just an empty game object. The background inside of it, though, this is the guy that I'm actually using as my like container for my items. And I have a script associated with this guy called the collection manager, which I think we created right at the end of class last time. But we didn't put any code into it. That's what you were supposed to be working with for your homework assignment. All right, right now it's just asking me for a single parameter. So let's go and look at that code real quick and talk through that. All right, so it's asking me for a single public game object, and this is just going to be our item prefab. So that thing I was just showing you. And the way you get to that, if I click on that and I go to my prefabs folder, I just took our item. Well, I got to click on background here. I just took our item prefab guy and I drug it over here. All right, so that's how you connect this prefab to your script, because ultimately in that script, we want to create instances of this item prefab. All right. Now, I'm going to go ahead and add just a couple of pieces of information here, to a couple more parameters for the materials, so we can update the material for this guy. So that when we run it, we see something more than all the same image. I'm just going to alternate the images. All right, because right now they're all this guy, and that's actually kind of inconvenient based on my text, but I guess sort of kind of whatever. In fact, well, let's go into the code. Let's give ourselves a couple of materials. So I'll go ahead and say public material, and let's call this guy placeholder material, and let's call it potion material. All right, so I'll give myself two public variables to hold our two materials. And what we'll do here is I'll go ahead and I gotta stop my game. We'll go into our background. We see that our script is now expecting me to give it a couple of materials. I'll go into those materials were in our images folder. Inside of materials, go back to background. So I'm going to give it the placeholder material first. This is our item placeholder. And then I'll give it our potion material there. So I have two different pictures. Okay, so when we converted it to a sprite, we get a material texture that we can apply to our objects. Okay, and we've used materials before. And now what I do, so now we'll start going through the code here. At this point, I'm not actually connecting it to the JSON. This is more creating the prefab with the behavior for the left and right arrows. All right, so inside of start here, I just create a loop that goes through 10 times. All right. Now I'm keeping track of several different pieces of information here. So we already saw the prefab that I want to create instances of. And now we see our two materials. I'm also keeping track. Now, these are all private variables, so these are just living inside of the class here. I want to keep track of the start position. And what that start position is, it is the center of this far left guy. That's the first one, because as I create 10 of these, I want to place one here, and then I want to move the next one over to this position, and then move the next one over to this position, so on and so forth. All right, now I'm placing 10 of them, but notice we only see 4. There are more over here, but they're currently disabled. So notice over here on the left, we see there's 4 turned on and 6 turned off. Okay, and we're going to look at the code and how that was accomplished. And it's all code we've done before. We're just putting things together into a single package. So kind of goes back to that statement of all hard problems are made up of a bunch of easy parts. All right, so there's nothing really brand new we're doing here. It's just putting them all together into a single fell swoop. All right, so we got our loop. We're going to do something 10 times. Well, what are we going to do? Well, I'm going to figure out what our current start position is going to be for the very first item we're placing. Notice I'm keeping track of a number of items spawned up here. This guy right here. So initially I have 0 items spawned. So when I set my start position, I'm creating a new vector 3, and it's going to start off at position. So this negative 3.7F, that's a position I figured out by just dragging I put an item in here and moved it over to kind of the far left of the background. And notice it's a child of the background. So this guy right here, has a position of negative 3.700. All right, so I just manually drug one in there to see where he started. And that is how I discovered this value. All right. Now, the first one I want to place exactly at negative 3.7. So what I'm saying is negative 3.7 plus this side item spawned. This is the number I've spawned so far, which is 0. So 0 times anything will be 0. So the very first time I do this, it'll be negative 3.7 plus 0, which is why the very first one will get placed at that far left position. And then I do increase item spawned by 1 each time through. So the second time through this loop, this will be negative 3.7 plus 1 times this 2.51. That's again something I kind of messed around with until I figured out how I wanted my items spaced from each other, putting them next to each other. So the second time through this loop, we'll have 1 times 2.51. So this number will end up being like a, negative 1 point something. So that'll move it closer to 0. So that moves it to the right. The next time through, it'll be 2 times this. So now we're in a positive number here, negative 3.7 plus 5. Third time through, plus 7.51, so on and so forth. All right. So each time through this loop, I'm updating this vector 3 to be a little bit farther to the right. All right, now this is where we're instantiating our game object from our prefab. So remember, I had brought in our item prefab here. So we have that public game object. This is our item that we designed. And that guy at this point is just a picture and a text mesh pro that is going to have some text in it. All right, so I'm going to create one of these guys with the instantiate function. What am I creating? I'm creating our item prefab. Where am I creating it? I'm creating it at the start position that I just calculated here. So the first time it'll be at the far left. The second time it'll be a little bit right of that. The third time it'll be a little bit right of that, so on and so forth. And then the third thing is the rotation. So I'm saying it Quaternion.identity is a rotation of 0, 0, 0. So no rotation. Just however I design that prefab, that's the default rotation it'll come in as. Okay, so at this point, this game object is not actually in our scene. I've just instantiated it in code. All right, now this next line is actually a little bit tricky. And let me show you why. So if I go into my code, it's all running right now, so I have access to these guys. So all these guys right here are the result of this line of code right here. Instantiating an object. Okay, so each one of those is a new instance of our item prefab. Now notice here, when I expand this guy, the top level object is this item prefab with our potion, and then a child of that is the guy who actually has our text mesh pro. All right. So we actually have 3 levels of transform here. So transforms are actually kind of like generic objects when it comes to our visual stuff here. So a item data, so the guy that has our text mesh pro in it, and notice my default values in there is just item 0, cost 5, just to let us visually see it. Notice also it has a rotation because when you first brought the text mesh pro in, it's laying flat, so I had to rotate it up. But in any case, so that's just a matter of manipulating it till it looks the way you like it on the screen at the prefab level. And then once you save it and you create instances of that prefab, it'll look the way you made it. All right. But the text mesh pro that I have here is actually part of a child of the item prefab, which is a child of our background. All right, so it's the background that is running our collection manager script. That script is creating these instances of item prefabs. And every time we create an instance of an item prefab, that comes with a sub game object. So a child of that guy that has the text mesh pro in it. So when I want to set that text, I actually have to go in and get access to that Text Mesh Pro, the one of the child. Now, you could certainly write scripts so you can drag and drop these things in and that kind of stuff. But if we want to be able to manipulate this stuff through code, this is how you would accomplish it. All right, so I've instantiated my instance of a item prefab. Now I want to get access to our Text Mesh Pro so I can set the text in there. So notice the name of our instance of our item prefab is called new object here. That's just what I named that variable. So I'm going to say new object, give me your transform. And now I want to get one of the children of that transform, specifically your very first child, the one at bucket 0. So what I'm saying is item prefab, give me your transform's first child, that guy right there. All right. Now, if I had 20 children underneath that item prefab, so indented underneath it, I could access the first one by bucket 0, the next one by bucket 1, bucket 2, so on and so forth. All right. So we're just walking this hierarchy of transforms here. It might sound a little complicated, but effectively it's a container with another container in it. And it just so happens that this container right here is the one that has my Text Mesh Pro in it. Okay, so to get at that Text Mesh Pro, I'm going to say new object, look in your transform and find your first child, which is a transform, which is a game object. Then get that guy's Text Mesh Pro component. All right, so this part right here should look familiar. This part right here should look familiar. And even though we've seen, things where we've made things children of other things, this is probably the new piece here where if we happen to have it organized like this, which I didn't actually have to have it organized like this, I accidentally dropped it in the wrong place, but then I saw it as an opportunity to talk about this, so I left it that way. So if you didn't run into this issue, that's fine, but this gives us an opportunity to discuss this idea of walking through the hierarchy of a transform given the top level game object. So here's our game object we just instantiated. We're going to his collection of, his transform, which is a location, position, or rather a position, a scale, and a rotation. But a transform is also a collection of potentially other transforms, 0 or more other transforms. In this case, there is a function called get child count, I think, for transform. So you can ask the transform, how many children do you have? And commonly, the answer will be 0. We don't have any sub-children, but in this case, we do have 1. So if I were to ask that, I would have gotten a 1 back. I know there's only 1 here, so I'm hard coding in and saying, give me your very first child, the child at bucket 0. So this guy right here will ultimately be this item.data subchild of our item instance. And then I'm going to ask that guy for his Text Mesh Pro component. And now I have that in a variable. All right. So once I have our Text Mesh Pro client, right now I'm not actually connecting up any of our text from our JSON. I'm just hard coding text. So I'm going to say Text Mesh Pro, TMP, that's the name of my variable. Set your text to item followed by whatever our count is for I. So it'll be item 0, then item 1, item 2, item 3, so on and so forth. Followed by a \n, which is a carriage return. So it'll kick it down to the next line. And then I'm just hard coding in a cost of 5. All right. Now, remember, kind of looking ahead a little bit here. Oh, I'm already in here. Is this our JSON one? Nope. This is our JSON one. Notice here I have a, actually, I don't even have cost in here. So we're certainly going to want to have some costs associated with this. But the idea is we'd have a name, the stat impacted, the modifier, and then we would probably then have a cost of, let's say that a cherry has a cost of 3. Just gonna steal that right there. And let's say a sword has a cost of 5. Let's add one more thing for right now. A potion has a cost of 8. And let's say this guy affects, I don't know, armor class by 5. So maybe it's a defense potion or something like that. So it makes you harder to hit or something along those lines. All right. So you can make your JSON whatever you want. But since right now I'm showing a name and a cost, I probably want to have the cost somewhere, even though I'm just hard coding it in my code currently. All right. So the idea is we'd read that stuff in. We'd get our, how many times will we go through this? However many times we have things in our JSON. Right now, I'm just hard coding 10 to get the mechanics of our thing moving back and forth. All right, so I'll get my start position. I'll instantiate my object. I'll grab the text mesh pro from the child of that object. I'll set its text to item 0, item 1, item 2, item 3, whatever. Then I'll effectively press enter and then just set all of their costs to 5 for no good reason. All right, now what I'm going to do is I'm going to take this new object and I'm going to take its transform and I'm going to set him to have a new parent. And that new parent is going to be this game object's transform. Okay, now this is going to be important related to the start position. This isn't important to get it to show up on the screen, but it's important for the start position because I want this guy to be relative to our background, which is the dude who owns this collection manager script. All right, so that's this game objects transform. So effectively what I'm saying here is I want to take our instance of an object we just created, and I want to set his parent to be the background. So notice that all these guys are children of background here. They live inside of background. So all of their positions, all of their local transforms will be relative to the parent. So if they're rotated some number of degrees, that rotation is relative to the parent's rotation. Their position is relative to the parent's position. So this item right here is at negative 3.7. That's not negative 3.7 in the whole scene. That's negative 3.7 related to the background's position. So it'll actually be like a negative 7 or negative 8 point something, 8.4. All right, if you were translating that to the whole scene. And actually, background's location is relative to the collection's location. So actually, we're at what was it negative before? That is negative, yeah. So the actual position in the whole scene would be like negative 14 something would be the location of this guy relative to the whole scene. But typically, it's easier to set your positions and stuff, especially if you're putting in placeholders and kind of spots to hang them onto in your scene. It's easier to set an item or a game object's location or its transform to be something relative to the parent, so that each thing is kind of this self-contained pod. So that if some point in the future I decide, oh, okay, I'm going to move the background to a different location, I don't have to go in and change the code for all these things because all those things will automatically update since their locations are relative to wherever the background currently lives. All right, so I can drag it around the scene and those guys will still show up. Okay, so if I take this guy here and I move it over here and over here, and then I hit play, they're still in there. I actually probably hid some stuff from the collection. So by moving it, I broke the background actually, but not our things inside there. You see they're still moving around and that kind of stuff. So I would probably actually want to move the whole collection, not the background. Go. We see the the potion blocks it a little bit, but that number is changing in there. All right, so I didn't have to rewrite the code. I just moved around our collection, which owns the background, which owns the collection of items. All right. So I take my new object that I've created and I set his parent to be, in this case, the background, the guy who owns the script. Then I set my new object's local position to be this start position here, which the very first one will be at negative 3.7 F 00. But remember, that's negative 3.7 F 00 relative to the background game object, the parent of this guy. That's what local position is. Set your position relative to the parent. I'll set his local rotation to be no rotation. So quaternion is just 0, 0, 0. Quaternion identity is 0, 0, 0. If you've had a linear algebra math class before, the identity matrix is the matrix consisting of all zeros. So you can have different size matrices. And when you say identity matrix, it's a bunch of zeros. And you can use that for multiplying matrices together it's kind of like multiplying by 1, or it doesn't change the value of it. And then you can use modifications of the identity matrix to produce other matrices and stuff. That's all math stuff from linear algebra, kind of unimportant here. What this means for us is it doesn't have a rotation. It's just whatever the parent's rotation is, that's what this guy has, because we're just putting it in there with no rotation relative to the parent. So if the parent's facing a certain direction, this guy will be too. Okay. So we're setting the object's local rotation and position relative to whoever his parent is, and that's right after we set his parent. Okay, so at this point, he's been instantiated. We've located him in the scene, and well, we've added him to as a child of our background, and then moved him around appropriately and set some text. That's what that code right there does. Create an item, set some text, position it appropriately in our scene. Now, this if statement is the guy that does the initial logic of, so since I only want to show 4 items at once, I'll run this again, you'll see. Notice that even though I've created 10 items here, only the first 4 are visible. If I click on this guy here and I turn him back on, he's there, right? But I had him deactivated. So this next portion of the code is what does that. I ask the question, so I'm going through this for loop 10 times, and I say, hey, if this is more than the 4th item I've spawned so far, since we start off at 0, if it's greater than or equal to 4, so the spawned item that's equal to 4 would be this guy right here. So if it's greater than equal to 4, because I've already placed 0, 1, 2, and 3. If greater or equal to 4, set him to false for his active. That's what turns the lights out on all of these guys here. If I turn them back on, you see they're there. So we're positioning all those dudes. We keep moving them over to the right, to the right, to the right. But I just turn off the lights on ones that aren't currently within the view of my background. They're not currently in my collection of 4. Okay. So that's what this if statement does. Says, if the dude I just created is more than the 4th dude, make sure people can't see him yet. And this is where I increment item spawned. So the first time through, item spawned is 0. First time through this loop, it's 0, then it's 1, then it's 2, then it's 3, so on and so forth. All right. And then I also, so lastly, in this little section of the code, I go ahead and I've created a collection up here of item game objects. So this is a list of game objects. We've looked at generics before. And we talked about this. This is kind of like Java's version of something called an array list. So this is a list in C#. Just like it's an array, but we can keep adding elements to it. If you want to just create an array of game objects that can hold 10 things, you could do that too. But in this case, I can have now 100 things if I want. Although, yeah, that would be fine. And this will let me add up to 100 things without changing anything else. All right, so I have a list built for holding game objects. This is our idea of generics that are in the notes. And what I do is after I create each one, he's already in the scene. I make sure I add him to my collection because I'm going to need to go and do stuff to that when I hit the left or the right arrows. So when I hit the left arrow, I need to move all my items to the left and then make sure I turn on and off the right ones. When something that just left my scene, my background, I want him to turn off because I don't want him hanging out over on the left. Something that just entered the background, so now he's in my top 4. I need to turn him on because we should be able to see him now. All right, so this is me adding it to a collection, so I'm prepared later on. I have access to all of the guys I created in my code inside of update to make changes to them. Okay, so before I go on, are there any questions about what I'm doing right there? Like I said, I am creating 10 items, 10 instances of items, placing them at specific spots on our screen and making several of them invisible. And then I'm storing those instances of the object so I can work with them later. I'm storing them in this list. So any questions on this part before I go on to our update? I'll take that as a no. All right, so this JSON stuff, that's stuff we looked at last time. So that's the homework was to connect that to this. So let's skip that for right now. Now we're going to come down to update. So in update, I've added 2 abilities. Respond to a left arrow, respond to a right arrow. All right, so every frame, if they press the left arrow and released it, let's forget about this and part for a second. Just when they press the left arrow, here's the stuff we're going to do. We're first going to create a couple of variables for temp left and temp right. My intention for these guys is temp left is going to be holding on to the far left element that we can see. Temp right is going to be holding on to the far right element that we can see. All right, so initially this should be 0 and 3. But as we press the left arrow a bunch of times, 0 moves to the left. So it might be, 3 and 7, for example. Or rather 3 and 6. All right, so, but these don't have values yet. These just, I brought them into existence to hold some value somewhere in this loop. So what does this loop do? This loop goes through our items and moves them appropriately and makes them visible / invisible as needed. That's what this loop, well, that's what this code right here will do. So let's walk through that. So this first for loop just says, we're going to take I on an adventure through all the items in our list. So we know we've put 10 things in there. So I will be the value 0 through 9. Okay, so start I off at 0. Keep going as long as I is less than the number of items inside of our list, which will be 10 in our current example. Each time through, make I 1 bigger than it used to be. So it'll be 0, then 1, then 2, then 3, all the way up to 9. When it becomes 10, this Boolean expression will fail. 10 is not less than 10. All right. So inside here, the current value of I is going to be used. So I'm going to get the game object associated with our item at bucket I. So the first time, this will be our very first game object we stored. I'm going to get its transform, and I'm going to translate it. Now, there's a couple different ways you can move this guy. You can say that I'm going to just change his local position to a new vector 3 and then just do the math inside the vector 3. You can do that if you want. All right. What I'm doing here is I'm doing what's called a translation. So this moves the position of something. And then built into the language, the vector 3 class has a whole bunch of static variables, static fields. So one of those fields is a field called left. All right. And the reason we know it's static is because we're accessing it using the name of the class that it's defined and not an instance of it. So I'm saying vector 3 class, give me your static vector 3 that represents a move to the left. And the default is a move of 1 unit to the left. Okay. Now I'm saying, you know what? And then again, this is just me fiddling with it until I got it to move enough that it was kind of, yeah, that's how far I wanted to move to look right. So it turned out I needed to move it 10 units. All right, so move it left 10 units is what that says right there. So I'm translating this dude right here, left 10 units. That's what that line of code does. Then I'm asking a question. So I'm going to do this for all 10 objects. So every time through here, every single one of our objects will move to the left 10 units. Now I'm asking the question, is the guy I'm currently working on, is he actually the dude who is currently at the left side? And if I'm moving to the left, the dude who's at the far left, for example, when I run this, this is temp left right now. When I press the left arrow, he's going to move this way regardless, but I need to turn him off. I'm going to make him disappear. So notice this is now item 1. Item 0 is over here. He's right here. So notice he's chilling over there. Okay, but I had to programmatically turn him off. So I said, if you're currently the far left guy, then I'm going to remember you because you just moved left. So now technically you're going to be off the scene. You're going to be off the background. So I don't want to see you anymore. So I'm going to remember you right here so that I can turn you off down here. So if this was the far left guy, let's remember him. If it was the guy just off the scene on the right. So the dude 4 elements later after the far left guy. That means if you're this dude, I want to also remember you. Because I'm going to want to turn you to be visible. All right, the guy who just left the background, turn him invisible. The guy who just entered the background, turn him visible. And then I want to update where my current left position is. Initially, my current left position is bucket 0. When I press the left arrow once, it's now actually bucket 1. This is the guy that lives at position 1 of my list. This is the guy that lives at position 2 of my list now. I just pressed the left arrow again. Left arrow again. This is the guy who lives at position 3 of my list. So on and so forth. I'm keeping track of the index of this guy in my list. So I can, and notice here, if you just see the 4 things over here in the left, as I hit my arrows, you see that always there's only 4 guys visible. And that's all being done with the logic inside of these loops. So every time I hit the left arrow, I'm going to go through and move everything and turn the right stuff to be visible and everything else to be invisible. So this is my code for the left arrow. Now I'm only going to let the left arrow work if my current left position is less than or equal to the number of items I have minus 5. And what that accomplishes is, you watch this as I press the left arrow. I now am showing everything to the right-hand side. So if I hit the left arrow again, I don't want it to shift anything left anymore, because I am already showing everything on the all the way to the far right of my list. Shifting it left again would make this guy disappear, then this guy disappear, then this guy disappear, then this guy disappear, with nothing left over here to fill in their spaces. So this is as far left as I can go while still showing items. Similarly, the same thing's true when I go to the right. I eventually hit a stopping point on the right, which is done with this and. If my current left position is greater than or equal to 1, I can't go to the right anymore. Why? Because there's nothing out over here to show next. I'm already showing everything at the far left of my list, so there's no more right that I can actually go. Okay, so right arrow does basically the same stuff, just a little bit different. And on this, it figures out temp left, temp right. It goes through all of our elements. It moves each thing to the right. So here's the right vector 3 static field inside of vector 3, 10 units. Then I ask if you're the guy who's just about to show up on the scene now, you were just off the screen to the left. I want to remember you, because you're going to get turned back on here. If you were the guy who was at the far, if you were the last visible guy on the right, you're going to move to the right a little bit more, and I want to make you invisible so we don't see you anymore. And then we're going to decrement the current left position. If current left position used to be 1, and I've pressed the right arrow, now it's position 0 that's at the far left. That's why I'm decrementing it. Okay, so that is the code that allows this guy to move back and forth. So what I'm going to do is I'm going to change the due date for the assignment that was due today. If you got it working, great, you get the weekend off. But if you didn't, and I'll update my code on GitHub to be this version of the code. So what I want you to do is update this stuff with the JSON data. So don't just hard code in 10 things like I've done here. Instead, have enough of these guys to cover the number of JSON objects you brought in. Okay, so because I want the focus of this to really be on this JSON data. All right, so questions about what I'm asking you to do? I'm just going to change the due date of the assignment. So it's the same assignment, but I've given you now kind of the movement code. All right, questions, comments, concerns, bribes. Okay, well, I will see everybody on Monday.
Dr. Littman.
Okay.
I do have one quick question. I couldn't get one of the pieces of the previous code going into the last assignment. I couldn't get it to work.
Can you tell me which piece? Is it in my code
Yeah.
or a bug in your?
It was in your code, but I was pretty sure I'd copied it all like the way you had it in your code on the GitHub. It
Okay.
was the for each loop when it was printing out them in the like the print. It was for each.
Okay.
It
And
kept,
are you getting an error or are you getting it just not?
yeah.
All
Yeah.
right. So give me a second here. Let me stop the recording.